This lesson is on graphing inequalities in two variables. The essential question is, how does graphing inequalities in two variables compare to graphing equations? When you answer this question, I want you to talk about the similarities and the differences between the two. Okay, linear inequalities in two variables. So there's an example of what that looks like. So x minus 3y is less than 6. So that's an example of linear inequalities in two variables. So you have your two variables, x and y, and it's a less than expression. The solution of an inequality in two variables is any ordered pair, xy, that produces a true statement when the values of x and y are substituted into the inequality. So we'll do an example of this. So here's an example. It says, determine if the points are solutions of the inequality. So when you do this, you must check all four of the points. Okay, so -1, 4 is our first ordered pair. So we're going to substitute -1 into the x plus 2 times 4, y is the 4 value, is greater than or equal to 7. And then you evaluate the left-hand side. Make sure you show your work. -1 plus 2 times 4 is 8, greater than or equal to 7. -1 plus 8 is 7, greater than or equal to 7. So 7 greater than or equal to 7, the point -1, 4 does satisfy the inequality. So -1, 4 is a solution. Now we try the next one. 8, -1, so x is equal to 8, y is equal to -1, so we plug that into our equation. 8 plus 2 times the y value, which is -1, is greater than or equal to 7. Evaluate the left-hand side to see if we get a true statement. So 8 plus 2 times -1 is -2. Greater than or equal to 7. So 8 plus -2 is 6. 6 greater than or equal to 7 is not true. 6 is not greater than or equal to 7. So the point 8, -1 is not a solution. So of the four ordered pairs, 2 of them are solutions to this inequality. A is a solution, and D is a solution. So next we'll talk about graphing inequalities in two variables. So the only way to show all possible solutions of an inequality in two variables is to graph it. So first we have to take a look at the type of line that we would use. So if we have the inequality without the equals underneath, just strictly less than or strictly is greater than, you would use a dotted line to represent the inequality expression. If you do have the line underneath indicating equal to with your inequalities, then you would use a solid line. And we will do an example of this in just a moment. The next thing is our shading. So we need to look at which side of the line we are going to shade. So if your inequality is greater than, or it is greater than or equal to, you're going to shade above the line. So you would go to the line, go up, and that's the side you would shade. If your inequality is less than, or it is less than or equal to, you will shade below the line. So you'll start on your line, you'll go down and shade below the line. So let's take a look at an example and how we would apply that. So we want to graph y is greater than or equal to 3x plus 1. So the first thing we want to look at is graphing the equation y equals 3x plus 1. So if it's in this format, it matches the y equals mx plus b. So we can identify our slope and our y-intercept. So the y-intercept is the point 0, 1. Remember, if you're identifying a y-intercept, you're always going to write an ordered pair. And our slope is the value for m, which in this case, m is equal to 3. Now we are going to graph the y-intercept, which is 0, 1. So on the y-axis at 0, 1. Starting at that point, we're going to use our slope to plot some more points. So since it's a positive 3, we're going to go up 3. So you're going to go up 3 and to the right 1. And that's where we're going to plot our next point. Okay, then we can go up 3 and to the right 1 again. Get another point. We'll go, since we went up right, you can also go down left. And the points will be in the same line. So down left. Next, we need to determine whether we're going to use a solid line or a dotted line before we draw our line through the points. That's where we go back up to our inequality, and it's always with relationship to y. So y is greater than or equal to 3x plus 1. Since there's an equal to part, we are going to use a solid line. Next thing we need to determine is whether we are going to shade above or below the line. So going back to our inequality, it says y is greater than. Greater than means above. So you're going to go to your line, put your pencil on the line, and you're going to go above the line. Okay, anywhere on the line above the line. So that is the side that gets shaded. So then you go through and you shade that side of your graph. And that is how you graph inequalities in two variables. Let's look at another example. So now we're going to graph the inequality x plus 4y is less than negative 8. So if your inequality is not yet in the y equals mx plus b format, you need to rewrite it. So here we would subtract x from both sides. And so on the left, the x's cancel. We get 4y is less than negative x minus 8. Remember, we want to isolate the y variable. So since there's a 4 with the y, we have to get rid of the 4. So we have to divide by 4. And when you divide on the right, don't forget to divide all the parts by 4. So we get y is less than negative 1/4 x minus, and simplify if you can. Okay, 8 divided by 4 is 2. So that would be minus 2. Okay, so let's graph, identify your y-intercept and your slope. So our y-intercept is 0, negative 2, and our slope is m equals negative 1/4. So we plot 0, negative 2 on the y-axis, and we're going to use our slope to get some more points. Since it's negative, we go down. So we're going to go down 1 and to the right 4. We'll plot another point. So we went down 1 and to the right 4. And then we're going to do it again, down 1 and to the right 4, and plot another point. We can also go the opposite direction. Since we went down right, we can go up left and get some more points. Determine whether we have a solid or a dotted line. So you go back to the inequality. Now when we go back to the inequality, you want to go to the inequality where the y is isolated. That's the inequality you want to look at. So y is less than negative 1/4 x minus 2. So y is less than. There is no equals under the inequality. Okay, there's no equals there, so we're going to use a dotted line. Then we need to determine whether we shade above the line or below the line. So again, you go back to the inequality where y has been isolated. Y is less than the expression negative 1/4 x minus 2. So less than means we shade down below the line. So here we're going to shade all of this part of our graph. And that is graphing inequalities in two variables. If you would like a practice just to check your understanding, here is another example. 2x minus 3y is less than 12. So you can work on this one in your notes and then restart the video to check your answers. Pause now. So this is the solution to graphing the inequality 2x minus 3y is less than 12. So if you need to check your work, you can pause again and then restart when you are done. Okay, just a couple of special examples. When we're graphing an inequality where only one of the variables is in the expression. So y is less than 1. So you find on the y-axis, where y is 1, we want to draw a line going through the 1. So we'll draw that line going through the 1, and when you draw it going through the 1, you need to be aware of whether it's a solid line or a dotted line. So you go back and look at your inequality and determine whether there's an equals or not. In this case, there is not. So we are going to use a dotted line going through y equal to 1. And because it's y is less than 1, we are going to shade below the line. Less than is down. So we want to shade below the line, this side. So that is the graph of y is less than 1. Last example, graph the inequality x is greater than or equal to 2.5. Since we're using the x variable, we go to the x-axis, find where x is 2.5, and we're going to draw a line going through that 2.5 on the x-axis. So when you draw that line, you want to be aware of whether you are using a solid or dotted line. In this case, there is an equals under the inequality, so we are going to use a solid line going through 2.5, and then we want to shade. So this is the only one that's a little bit different. All the other graphs you go up or down. If it's greater than, you go up. If it's less than, you go down. This kind of a graph is the exception. So x is greater than or equal to 2.5. So it's greater than. What we want to do is shade the side of the line where the numbers are bigger than 2.5. So that would be to the right. 3, 4, 5, those are all numbers that are bigger than 2.5. So we are going to shade to the right of our graph. So this is the side that gets shaded. And that is graphing inequalities when only one variable is present. So next class, we'll review graphing inequalities in two variables.